Thanks for having us. It's super cool. It's awesome to be here in Poland. I got to see a little bit of the city today walking around, so it's a pretty cool experience. I'm going to be talking very quickly about, I'll try to keep it to like half an hour, about Spring Cloud Kubernetes, which is one of our, I guess, the newest official project in the Spring Cloud umbrella there. Just by way of introduction, my name is Ryan Baxter. As you know, I work on Pivotal. I work at Pivotal. No. It's a lie. Yeah. Oh, I'm in the wrong place. And we're in the Spring team at on the Spring Cloud project. Before this, I worked for another small company called IBM, which I'm sure no one's ever heard of. But much happier to be here now, doing this stuff. So I have a bunch. Usually this presentation is much longer, so I'm going to skip some of it for time purposes. But who here, is anyone using Kubernetes? Okay, cool. So some people are. Anyone deploying boot apps to Kubernetes? Kind of, maybe. There's some hesitation there. So I think everyone, we have a lot of choices as far as where we deploy our applications. And I'm sure many of you have seen this kind of chart before, where we have this various cloud options, whether it be infrastructure as a service and all the way up to something relatively new like functions as a service. And really the difference here is what you're managing versus the platform's managing, right? So at one end of the scale, in infrastructure as a service, you're really managing everything from the operating system up the stack, and at the other extreme, you have functions as a service, where really the only thing your unit of deployment here is a function, a small piece of code. And we have everything in between, right? I'm sure everyone's heard and maybe played around with Cloud Foundry, which is a platform as a service, but in between platform as a service and infrastructure as a service, we have this containers as a service type of model, right? Where your unit of deployment is really a container. And typically historically from a Spring Cloud perspective, where you deploy your applications, it doesn't particularly matter to us, right? Whether you're running your apps on your own hardware in your own data center, or you're using something like infrastructure as a service, or you're taking advantage of a function as a service, right? With our new Spring Cloud function project, which Oleg's going to talk about a little bit later. It doesn't really matter, right? We don't really care. But with the container as a service model, it's some of it can be slightly confusing, right? So when we think of containers as a service, we think of Kubernetes, which is a platform that's used to kind of manage your containers, right? And containers are all great. They're great pieces of technology in some cases, but when you have hundreds of them, oh, Marcin. When you have hundreds of them, you need some way of managing them, like whether you want to scale them up or down, or have something that automatically restarts them and stuff like that. So Kubernetes provides a lot of that type of functionality. And packaging a boot app or a Spring Cloud app as a Docker container is pretty simple. But what starts to become a little complicated is when you start to combine some of the functionality that's in Spring Cloud with what's already present by the platform in Kubernetes, right? So Kubernetes provides some of the stuff that Spring Cloud already provides, so there's a lot of overlap. So you already have a service registry and the concept of service discovery built into Kubernetes, and we have that also in Spring Cloud. We have this concept of config maps and secrets, which allows you to externalize a lot of configuration out of your application and manage it in the platform. And Spring Cloud has the config server, which does the same thing. It's very easy to route requests between different services and pods and whatnot within Kubernetes. And obviously we have a facilitation for doing that in Spring Cloud with Ribbon. And then we have, Kubernetes provides some concept of health, whether the application or pod is healthy or not, and we have that as part of boot as well. But like a lot of this stuff was not really integrated into the application of the stuff that's provided by the platform, right? So the whole purpose of Spring Cloud Kubernetes is to kind of marry these two things together so that you can use the APIs and functionality that you're familiar with in Spring Cloud, but leverage what the platform is providing underneath the covers. Spring Cloud Kubernetes was first introduced as part of our Greenwich release train, which is our latest release, and requires Spring Boot 2.1.x. And here we integrate, when you add Spring Cloud Kubernetes to your application's class path, you get service discovery provided by Kubernetes using this traditional service discovery that's part of Spring Cloud. Your configuration data can be surfaced into the application via config maps and secrets, and you also get the concept of automatic refreshing. So if you change something in your config map, that automatically is reflected in your application as well. The ribbon routing functionality that was there in Spring Cloud leverages the service discovery, which, as I just said, takes advantage of the service discovery provided by Kubernetes, and we also add some application health to the health indicator in Boot. And so one of the coolest things about this project is that up until most recently, this project has been completely community driven. So it wasn't most of the development here has been done by the open source community and not necessarily people from Pivotal. So it's one of the few projects that are like that. Not the few projects, but that's almost been 100% community driven. So that's pretty cool. So I just wanted to show you guys a quick little demo of how this works. So let's see if the best way to explain this is, I have a couple of different, it's kind of like almost like a commerce type of application. There's a couple of different services, a couple of different apps here. There's a couple of projects, but I'll tell you the important ones, right? There's a couple of different services, right? There's this fashion service, just services some REST API with a bunch of fashion items, and same thing with the toys service, right? There's a bunch of toys that is via some REST API, and then there's this hot deals, which is like, things that might be on sale or whatever. And then we have a gateway, which is leveraging the Spring Cloud Gateway project that sits in front of that, right? So we take a look at the POM. We are using Greenwich here, right? In this case, I'm being slightly dangerous and using build snapshots. But this is in Greenwich release and SR1 as well. And if you look at, I'll just take a quick look here, like at this dependencies here, right? I'm adding, you can see I do have some of like the traditional Netflix, Eureka dependencies here on the class path, right? And that's because when I run the app locally outside of Kubernetes, I will still want to do service discovery via Eureka, but that's turned off via profiles when I run the app in Kubernetes, right? So we disable Eureka when this profile is set, which is Kubernetes, and then we take advantage of the Kubernetes dependencies here, right? So we have Spring Cloud Starter Kubernetes, and we have some config stuff here for integration with config maps in Kubernetes. I'll show you just quickly, there's nothing really special going on in the code at all, right? See, we just have a REST controller here. There's nothing you guys haven't seen before, right? And the application class just has enable discovery client, which is the same annotation that you're used to. I do have a Docker file here, right? So everything's built. This is just a general Docker file that you can find following the Docker guide on the Spring Guides website. There's nothing crazy going on here either. So pretty general app, right? So I have all this. How do I get out of presentation? Oh, okay.
View.
No. We're going to leave it like that for now. Okay. I have all this deployed in Kubernetes, running locally on a machine here. Unfortunately, I can't make this. I don't think I can make this bigger.
What's this actually?
This is a cool little. I don't know if it's available on anything else but OS X, but it's Kubernetic. So it's like a UI for Kubernetes. Yeah. I can make it full screen, but I don't know if I can make the text any bigger, so I apologize about that. But I have deployment for each one of those apps that I just went over here, right? That's all this is. And I have them exposed via services here. So for example, if I want to, I'm just going to hit the Toys app, right? So I'll start out there. Yeah, that I know how to do. Oops. So that's all that app returns, right? Okay. And what I can do here, so if we go to, if we go to here /actuator/health, you can see here's the health endpoint, the contribution from Kubernetes here. Right? So you can see some information about the pod that the app is running in, the IP address, etc. The status from that is up, right? So that's one of the features we talked about. And then the other thing I want to look at is the env endpoint, right? So this is all the environment variables. And you'll see here, oops, I scrolled way too far. Back down. Here. If I can find it, it's probably better to do in the browser actually. But here's this config map, okay? Here, so this is coming from this configuration map here, right? So I have it's basically looking for a configuration map with the application name. In this case, it's toys-bestseller, right? That's how it's identifying this. So if we view this, again, I'm sorry, I can't make this bigger. But there's this property here, chaos.monkey.enabled equals true. All right, so I can change that, for example, if I edit this and switch it to be false. And then we go back here and look again. Here you can see now the properties switch to false, right? So that's that config refresh that we were talking about. I'm actually going to switch it back to true because I want it to be true. All right, and then the other thing. Okay. Oops. Oh. Just, okay. I hope it's actually true. I don't know. Edit. Oh yeah, sorry, I do want it to be true. Yeah. Now I'm confusing myself. I don't know.
Conflict?
I don't know as a conflict though.
It needs to be refreshed or something.
Yeah, but why? I don't even know how to refresh it in here. This is what I get for using new tools that I'm not too familiar with.
So you're saying it's a cool tool, right?
It has worked perfectly fine up until this very second. This is just a little easier to view. Are you kidding me? Sorry. All right, it's not true. I want it to be true. It's not terribly important, but config, edit, true. All right, That seemed to like that.
Oh, much better.
There we go. Okay, now it's true. I just proved it worked again. All right. Yeah, so then the gateway also has an endpoint here that just basically you can proxy different requests. So if I go get that, just need to look up the port here for the gateway. So I can proxy this request over to the bestseller, the toys bestseller application, right? And the reason why I wanted that to be true, because that chaos for Spring Boot plugin basically injects random failures into things, right? So there's a timeout there that's being randomly injected, and the gateway is protecting the endpoint with a Hystrix circuit breaker. So that's why you see this fallback equals true sometimes when that random thing happens. So we also go to the other endpoints just to prove they work, right? So this is what the fashion endpoint looks like, right? And then there's the hot deals one. Hot deals, okay. All right, so, and then there's one endpoint in part of the gateway that aggregates all this stuff together. So the start page here, you can see this has the fashion and the hot deals response, as well as the toys response, but in this case that fell back, right, because of the timeout. There we got the actual stuff, okay? So it's basically just proving that all these applications, like I said, there's nothing special about any of these applications. They all work just as you expected, but they're just using the Spring Cloud Kubernetes project as opposed to anything else like Yurk or whatever. And you can just straight up build a Docker container with them and deploy them and take advantage of all the stuff in the platform. Now, some of the things that we've been looking at, which I'll show you that I've been playing around with lately. Has anyone ever heard of telepresence before? Okay. Where is this? Oh, there we go. Ah. All right. So one of the things that always bugs me about Kubernetes is like trying to debug things when things are running in Kubernetes. So this provides a cool way of doing that, right? So what I'm going to do basically is use telepresence, which is a tool that can swap out containers that are running in Kubernetes, and this is going to swap, in this case, the gateway container or the gateway pod with this pod that's going to set up a two-way proxy that's going to actually proxy a request down to my local machine. And I'll show you that I can then start the app in IntelliJ and then set breakpoints and debug things as if it was running inside of Kubernetes. So when I do this, it's going to do its magic. And you can see, if I had showed you before here, there's two pods that are running here. Now that you say that, Spencer, I wish there was a way to refresh this, because now I want to show you that one of these is going to go away. But
But it is going away.
no, it did. Oh, did it?
It was terminating. Right?
Oh, it's terminating right now. Yeah, so that one's it's going to kill that one. This is the one that's going to start up. Yeah. So yeah. So this is the new pod from telepresence. So how do I get? I want my. All right. I'm gonna this. Yeah. All right. Because I want to show you this, or I need this here. So telepresence creates this environment variables file here, which is, I know you can't see, basically IPs and ports for all the other pods that are running in telepresence. So you can configure your app to run with all these environment variables. It's not particularly important in this example. It might be important for your specific app, but it's not in my case. There's one thing that I do need to add. just to make sure that this all works fine. This is a environment variable that Spring Cloud Kubernetes expects to be there when you're running Kubernetes. So this isn't like the cleanest demo ever, but like we'll make things cleaner eventually. But this is stuff I've literally just been playing around with the past 2 weeks. So if I now start this app in debug mode from IntelliJ, right, it's going to start it up just as it normally would. But basically there's, again, a two-way proxy set up in Kubernetes, and also telepresence is proxying requests from my local machine up to the cluster as well. So if I go to here and I make this same start page, let me make sure I have a breakpoint set somewhere. That's going to help. Okay, I do. So I have this conditional breakpoint. Well, I had a conditional breakpoint set. Condition if toys dot response type dot equals response type dot fallback. Okay, so I'm only going to trigger this breakpoint to be hit if the toys response times out and we get the fallback from the circuit breaker. So if I hit this, hopefully that random injection happens here sometime soon. There we go. So again, that's proxying the request, right? This is going to the node port in Kubernetes, right? And Kubernetes is proxying that request down to the app running in my local IDE here. So now I could debug this and see what's happening, right? I can see, oh, the toys response is a fallback, right? And I get all my normal functionality that I normally would with debugging an app in my IDE, right? Except everything's running as if it was running in Kubernetes instead. So I could also do things like if I change config maps and stuff like that, it would all be reflected in here, like that automatic refresh stuff that we saw before.
So I understand that whole system is working on Kubernetes and one application is running.
Right. Right. So I told telepresence to replace that one pod that's running in Kubernetes and proxy all the requests down to my local host machine. And in theory, this also will work if your cluster was running in something like GKE, right? And you could do the same thing. I haven't tried that yet. That's one of the next things that I want to try. But
the proxy will need your IP of some sort, right?
Yeah, so that's some of the questions that I have, like some of the things, the next steps I have to try and figure out how to do. But in their documentation, they say that should work. But yeah, there has to be some way of knowing where my machine, where everything should be routed to. Yeah.
Is there a TCP?
What's that?
Is there a non-HTTP request?
I'm not sure actually. I didn't look at what exactly it's proxying, if it's just HTTP or not. But that's a good question. I'll have to go back and look at that. Yes. So any other questions? So pretty much half an hour. Anything else? Cool. Thank you.
Hello, everybody. My name is Oleg Zhurakousky, and I'm part of the Spring Cloud team. Currently juggling my time between Spring Cloud Stream and Spring Cloud Function, leading the effort on both projects with the help of Dave Sire. I was here 4 months ago. So how many of you been to the previous presentation aside from me? Okay, just nobody. So you see it for the first time. All right, good. Because I was afraid that I'm going to repeat myself a lot. Yeah, my story in Spring Source was quite interesting. I started in 2008, and in 2012 went to wander around, and then decided to come back. What a great company it is. How many of you use Spring Cloud Stream? You don't count. Neither do you, Dave. Spring Cloud Function? Have you heard of either one? Oh, I could have done the whole presentation now.
Go ahead.
So, Spring Cloud Stream. How many of you know Spring Integration? All right, so for those of you who are familiar with Spring Integration, it's kind of the messaging framework based on enterprise integration patterns provides the components necessary to assemble this sort of cohesive flows from simple abstractions like filter, router, aggregator, splitter, and so on and so forth. So one of the, and this is how kind of where I was spending my first tenure in Spring. As powerful as it is, there was certain limitation as we getting into the whole distributed world of microservices, where Spring integration, sure you can configure your ins and outs with inbound and outbound channel adapters, but the reality was it was just too much work to do it on your own. So Spring Cloud Stream is a binding framework which allows you to either use those flows internally or just simply create a very simple microservice. And the binding framework that we provide, in other words, it's a Spring Boot application, you run it within its sort of a container, and we bind that code to the messaging brokers like Kafka or Rabbit. So in other words, you write a simple code within the context of a Spring Cloud Stream, and all of a sudden, when you start the application, it will create the queues, the topics, and everything else will connect your code to those destinations. So now you can send the message to a destination, all of a sudden your code gets executed and you didn't really do much about it. So let me demonstrate quickly what it would look like, especially for those who do not use Spring Cloud Stream. So this is a very basic, let's just disregard all this stuff. This is a very basic kind of rudimentary Spring Cloud Stream application. So this is all the code. There's nothing else here. So Spring Boot application, you do enable binding. We provide 3 different, what's the word I'm looking for? Not obstructions, but God. I went to Ukraine for a week. I forgot to speak English. It's not stereotype, but okay, let's just call it stereotype. So we have source, processor, and sink. Essentially, annotation. Martin, can you let me speak? Types, yeah. Well, types. That's not the word. I forget. But anyway, so we provide a stereotype. Probably would be the more appropriate. So it's a source, processor, and sink. So source means that there is no input coming in. You're the data producer, and the sink is the opposite of that. Data comes in, but nothing comes out. And the processor is data comes in, data comes out. So so in this case, processor is the easiest one to demonstrate because you can send something, you can actually receive something, right? We can. So in this case, I enable binding. So that's I'm declaring that's going to be a processor or a source or a sink. You can also declare custom bindings if you want to, and there are use cases for that as well, but kind of out of scope of today's discussion. So, and then you write a simple method, in this case uppercase, and you say it's going to receive the value of type string, and you can basically provide your code, which, as you can see, has no relation to Spring or anything else. It's just plain old Java code, and again, you add a few extra annotations to kind of give a framework a hint that this is the method that I want you to execute. And you say that bind this method to this input and this output. So those are Spring integration, well, Spring messaging, but implementation provided by Spring integration. Those are channels, right? And a binding, when I say Spring Cloud Stream is a binding framework, what it binds those channels to the inbound and outbound adapters that within Spring integration. So that's because we're using Spring integration internally within Spring Cloud Stream. But forgetting Spring integration, it binds the channel to a remote destination. So in other words, if I'm going to send, in this case I'm using RabbitMQ, so I'm going to send message to RabbitQ, and this queue, the mechanism within the framework will delegate this message to this channel and essentially invoking this method. And obviously going to the output is going to send it to the output destination, output exchange, in this case. So, I'm going to run it. You guys see the code? Much better than IntelliJ, right? So, The only thing, so as far as so this is all the code. Now you're asking me like, was there any configuration? So technically I didn't have to have any configuration whatsoever, but having no configuration whatsoever is not demo friendly. So I provided, and I'll explain to you in a second. So here's the only configuration that I have. So basically I said that the input channel should be bound to this destination. And I called it rabbit input group. So I provide a group name and destination name. Why? So it will create a queue called rabbit input group, right? If I didn't do that explicitly, it would create a queue called rabbit input dot and some gibberish, UID or something, and it wouldn't be durable, which means every time I restart the application, it would be deleted. So like I said, it's not demo friendly. But technically, you don't need to do anything at all. The code that you've seen is enough, right? So now we're going to send the message. We're going to send hello stream and publish message. And now we're going to go back. So what I did in my exchange, which is the rabbit output, it's bound to out queue. And now I'm going to go to queues, and you can see there's a single message out there, and we can go check what that message is, and hello stream uppercased, right? So again, very simple way of creating messaging applications, okay? Now, of course, there's more to it. Like I said, usually it's like an hour and a half presentation, but I'm skipping a lot of things, but we can talk about this during the free talk. Now, and this is kind of my favorite part, like when I took sort of the leadership role for the project, I wasn't really convinced that this is we live in the world of evolution, for those of you who believe in evolution.
Earth is not flat.
Right, so we kind of evolved from first few annotations, we got everything working great, but could this be simpler, right? And the issue is that for me it was like, okay, we're kind of again mixing code and configuration. So in other words, there's some configuration in the code and there is some configuration outside of code. So, and that's when Dave Sire and Mark Fisher were at the same time when I was thinking about this. They were working on a Spring Cloud Function project, and we kind of started toying around with the idea that I want to bring Spring Cloud Function into the Spring Cloud stream. And so we did, right? And I did this presentation kind of less time, but since all of you were not here, well, here's a different way of looking at this. So I'm kind of skipping a lot of things, but let's discuss it for a little bit. So first we had stream listener, send to, and so on and so forth. Now we're using functions, just plain old Java util functions. Now, when I mentioned the source processor and sync, and again, I'm still looking for that word, but the interesting thing about this that I immediately would start looking at this, okay, well, we have, since Java 8, we have Java util.functions, which provide us with supplier, function, and consumer, which map one-to-one to these stereotypes of source processor and sync, right? Now, the benefit to use Spring Cloud, to use function, is that source processor and syncs, those are the concepts identified within Spring Cloud Stream. So you kind of have to know a lot about the framework. But when you're writing functions, you're literally just writing plain old Java function. If you look at this piece of code, it does identical thing that the code above, but it has no annotation, only has one Spring annotation, which is @bean, right? And that's pretty much it, right? And you write a plain old Spring plain old Java function. Now, the benefit of it, you can test it as a plain old Java function. In fact, you can develop it completely without Spring whatsoever and put it in a library like a jar file, right? And then create your configuration, say bootstrap these functions and so on and so forth. So it doesn't even have to be implemented within your code itself. And kind of provides you with a very convenient model, because now where this whole evolution took us is that now we have, and I'm starting to like sort of create this mottos like write once, execute anywhere, or invoke it from anywhere, because when you write a function, and I'll show you in a second, so now applying Spring Boot principles, you can actually say, okay, I'm going to have one function with an application context, but depending on what else is in my class path, right? So you kind of manage the dependency injection managed by the POM, right? So depending on what's in my class path, this function could be part of this framework or both for that matter, right? So let's see what's going to happen here. So I have a single function. Also, one of the problems is that when you're writing Spring Cloud Stream application, you kind of already see that it's a Spring Cloud Stream application because you have this proliferation of all these different annotations. Well, you no longer need that, right? So in this case, and that's something that when I was here last time, we didn't have this functionality. You still kind of needed to provide something, right? So in this case, we have Spring Boot application, and if you remove all this enable binding stuff, you remove all this, all you see right now is just a plain old Spring Boot application. It's not Spring Cloud Function, it's not Spring Cloud Stream, it's nothing. It's just a Spring Boot application with a single bean of type function, right? So let's start it up and see what's going to happen. Okay, everything started. So we still have this queue. So let's just purge this stuff out. Okay. And we can see that, well, it executed, right? And we can go and check whether it executed, and it did, and we got a message. Hello, Marcin. Now, what has happened here? So basically, because we have, and this is the time when I'm going to show you the POM. So in POM, we have basically declared dependency on Spring Cloud Function and a few extra other things that just related to the demo. But the bottom line is that there are dependency within their dependency on Spring Cloud Stream. This is how it is a Spring Cloud Stream application, but now we basically added the dependency on Spring Cloud Function, and all of a sudden, this function was bootstrapped as a message listener. So now, when I send a message to it, it executed this function, right? Well, how did it know which function? How did it figure it out? Well, again, by convention, we only have one function, right? It's not hard for me within the context of a Spring Cloud Stream to figure out that within Spring Cloud Function or Spring Function Catalog, if there's only one function and you're executing this function within a Spring Cloud Stream, then you probably want it to be a message listener, right? So we essentially created binding dynamically and bind it to these type of to the internal channels, which themselves are bound to external destinations, right? Here's what makes it even more interesting. Remember when I said write once and execute it from anywhere? This is kind of sort of my favorite part. So we have a function called uppercase, right? Container is still running. I executed it by sending a message to a queue. Well, I can also send a message to it by basically executing as a REST endpoint. So it was exposed as a REST endpoint. Why? Because we simply have a dependency on Spring Cloud Function Web, right? That itself is kind of an adapter, which also exported this function as an endpoint. So all of a sudden, I have two ways of invoking this function within a single application context, right? So without changing the function itself, right? So, and again, one other thing that I'm kind of sort of skipping mentioning it, right now I'm executing very simple inputs and outputs like strings and so on and so forth, right? If I were to go into the whole POJO world and stuff like that, the framework both either on the REST side from Spring Cloud Function and on the Spring Cloud Stream side provides the message conversion, type conversion, and everything else. So you can send a JSON payload and then it's going to be converted to whatever type you declare within your function or within your listener. And if we're going to have enough time, I can demonstrate that as well. I don't want to take too much time, but let's take it one step further. So let's declare two functions, right? Now here's what's interesting. So in a world of spring load function, when I started it, I couldn't quite understand why the lowest denominator is flux, basically reactive libraries, right? So I could never understand why we support flux, but also if function is not flux, like this particular function, why are we transforming it to flux, right? So, and until I kind of started playing around with this, it kind of, I was like, this is actually really cool. So, well, there's many cool things about reactive, but this part is particularly cool. So now we have two functions. You can see that both of them, one of them is kind of imperative, one of them, and the other one is reactive, right? So if I try to start this right now without providing any additional information, what do you think should happen? What type of error? Right, we don't know, so basically it's a conflict. So if I try to start it, we're going to have an immediate error because it says failed to determine which function to bind, more than one function available. And in good Spring fashion, we always provide you with a hint what to do. So say define Spring Cloud function definition property, right? So what's Spring Cloud? So in other words, now as your application gets complex, you're opting in to add configurations, additional configuration, but only enough to get you past that point, right? So you don't have to provide configurations that we can figure out on our own. At least that's what we try to do. It doesn't always work, right? But so again, it's a property, just any other property, so you can define it in the configuration file, like YAML file or properties file, or you can just for the demo purposes, you can just say equals uppercase, right? So if I state, so right now I broke the tie. So I have uppercase and now everything is back to normal, right? But why did I declare two functions if I only intend to use one? So I probably intend to use two. So I'm going to do this. Basically, I've just composed two functions into one and then bound them to. So in other words, now you can see how you can, again, in a good old Spring fashion, you work on a single requirement at a time, you address one problem at a time, and you can now, with the functional programming, you can actually compose a complex problem out of a set of little problems, right? So in this case, I have one function that does uppercasing for me, another function that does string reversal for me, and I can, again, obviously imagine that those are going to be much more complex requirements, but you can address them in isolation, you can test them in isolation, and then you can compose them once you're done into a single function, right? So in this case, so now, even though I have two beans or two functions in function catalog, what's going to be bound and Bootstrap is going to be a single function, which essentially is composition, yeah. Okay, so. Well, anyway, so I don't know how much time I have. So what's interesting about this particular example is that we have two functions that are, for example, when I talk about function composition, so again, forget about Spring Cloud function. Function composition exists, are given to us by Java utility functions, right? So you can say, you can have two functions, function, and then there's a method called and then. You can say function dot and then this function and then this function, so you can compose them. But you can clearly see that this is not, it wouldn't be simple to compose these two functions because they're not sort of composable in a plain old Java world because their input and output parameters aren't really compatible, right? So, but at this point of time, because this is like one of the value that Spring Cloud function provides you, because it's like a canonical format is flux flux. So in other words, this function internally is represented as function flux string, right? And therefore it is composable now with this function. So, and that's really where we at. So, yes?
So it's not possible then to send a list of strings into that composed function? Is that right?
List of strings.
So if I want to say Dave and Oleg, then uppercase both of those words.
But that would be a
So
single.
two separate strings, right? Two separate strings.
You send one at a time.
Messages,
Yeah, it's separate messages, yeah. So, but I mean, I guess this is really up to the binder because, let's say hypothetically, because within, actually it's a good question. So within, so the question is, what if I want to send multiple strings because everything is flux, right? So I can just stream through this, right? Well, the reality is that that's already goes outside of scope of Spring Cloud function because that's the actual binder, right? So right now we're binding these functions to a message listener container provided by Spring Messaging as well as Spring Integration, right? So what ends up happening is that there's basically a message listener that we create internally, and then there's a function invoker which kind of creates the flux and translates the conventional message listener model into sort of flux, right? So if we were to, like for example, there is a Rabbit reactive. Now, if we could write a binder that directly binds to reactive inputs and outputs provided by the underlying framework, then yes, you're right. Because, and again, it's not really about the list. You're just simply sending a stream, right? But in this case, if you send the list, the flip side of it is that we're going to accept it and I'm going to say, okay, well, can I convert a list to a string? Because in this case, the invocation model will say, okay, well, I'm receiving a list, but we do the type introspection and we see that your required input type is string. So now the message converters come to play and they say, okay, well, is there a message converter that can convert list to string or vice versa? Like, and that's what I was saying before about the POJAs, where if the input is like foo bar, and then, you know, you will, the message converters will kick in. Okay, before I finish, I wanted to show you something. Like there's so much we could talk about, but I kind of want to put your attention in this cool thing. So we're all familiar with the typical Spring dependency injection configuration model, where you declare application context, you declare a bunch of beans, and everything's fine. So, but at least in the old days, you control which beans, you know, starting from XML and so on and so forth, or annotation, you control which beans you want, your connection factories, this or that. With Spring Boot, we do end up sometimes with a lot of stuff that we may or may not need, right? And that a lot of times affects the start time and other factors. So with the application context initializer, you can kind of go full functional in your dependency injection model. So in this case, we again have two functions, but you can see those aren't even beans, those are just methods that will return you a function. And you provide actually
And myself,
yeah. Dave Sire wrote a really nice blog on this, so you can Google it. Right, but yeah, those could be private. Yeah, let's change it during a demo, Dave. Right? Like I didn't have enough problems, right? So, and you know, a little bit of legwork, but you have full control. You still have Spring Boot benefits for certain base configuration, right? In this case, so a couple of things we changed. We made our application implement application context initializer, which requires to implement initialize method, where we're going to use this new Spring API, where we're going to register beans. Okay. In this case, we are registering not functions, but function registrations. Why are we registering function registrations? Because this is, in this case, we're sort of bypassing a lot of things, and we create function registration carries information about the type and everything else of a function. So in this case, because we don't really bootstrap the entire mechanism of Spring Cloud function, where we do the introspection, because all that affects the startup time. We do the introspection on the method and determine which input parameters and output parameters, right? In this case, you provide, you simply declare what they are, and all that is essentially a wrapper over a function, right? So you provide the target and then function type for that target. So now we know, for example, when it comes to invoking this function, we still are aware of the input and output type of this function for type conversion and other things.
The problem it's solving here is just type erasure, right? You can't tell at runtime what the input and output types are.
Yeah. Yeah. So in this case, again, it's hard to determine right now, the cost of a startup time because everything is just so simple. But I would suggest for you to read Dave's blog, and he provides the numbers, and he spent like the last 4 or 5 months just showing how fast Spring can be. Well,
Time flies, right? Feels like 4 months.
yeah, I meant years, but I said months. So anyway, we can, I can start it up and then do the same thing with the web, but you already seen it. So the bottom line is that there's basically a different mechanism for you to bootstrap functions, and again, there's more to that, to functions and stream, but I'm out of time, so thank you.
In this model, if you want to have various functions depending on the, let's say, queue that the message comes from, is there an easy?
Okay, so so I actually, so we all gathered here, well, us, 4, 5, 6 of us, primarily so we have our annual face-to-face. So this is one of the things we're going to be discussing tomorrow. So the question is, right now we have single input, single output, and last time I was here, I was actually arguing about whether there is really a valid use case in the concept of a microservices for subscribing from multiple inputs, because I'm saying, okay, well, if you're subscribing from multiple inputs, you have 5 or 2, 3, 4 different listeners. Is it, why aren't they different microservices themselves, right? But there are cases where, for example, you need to listen from 3 streams and merge them, join them, or you need to sort things out, like a typical big data case where you receive a dump of data and then you need to put accounts here, which goes this queue, and then the orders there, and something else, somewhere else. So the question is, is there a way, and are we thinking about providing a mechanism within the scope of Spring Cloud Function and Spring Cloud Stream where we'll be able to send and receive as a function, receive and send multiple inputs, multiple outputs. Now, function obviously defines single input, single output, right? So there's a by function, but okay, so you have 2 inputs, 1 output, right? But that's about where it stops, right? So, so I actually, I have 3 different ideas that I want to discuss tomorrow. But yes, it's coming. I mean, the point is that it's no longer a question of whether we should, it's just a matter of time. So, and this is like, we're about to release Spring Cloud Stream 2.2 and Spring Cloud Function 2.1. So that functionality will be coming in the next feature release of Spring Cloud Function and Stream, depending on...
You do it without Stream Listener, right? So it seems like it's a strange...
But, right, so they would mention in a Stream Listener we can do that, right, with the Stream Listener model, the very beginning that I showed you. But I didn't want to be motivated by what Stream Listener provided us with. I wanted to say, listen, what's the real use case? Because I don't want to just mimic what Stream Listener does, rather than just to say, let's apply it to the real problem. So, and Jakub challenged me the last time I was here, and it kind of started the ball rolling, and there was a few other people, and KStream, Sobi, just there's a PR out there for KStream. We have Rabbit binder, we have Kafka binder, we have a Kafka Streams binder. For KStream, that's a very prevalent use case. He basically says that what he observing from the community, the 3 inputs is kind of a sweet spot for this type of use cases. So yeah, it's coming. Thank you for reminding me.
Can we do some docking operations inside the function, like calling database or something like this?
Absolutely. That's another very common use case. In fact, We were actually debating it recently where, I'm saying, okay, well, Spring Cloud Stream application starts, like this performance issues that, okay, Spring Cloud Stream application starts in an amount of milliseconds. If we can cut down maybe another millisecond or two, and it's kind of I realize it's a primitive way of looking at the application, because maybe my application as a pure Spring Cloud Stream starts that quick, but when it comes to, database configuration, other configurations, so we're considering which configurations or which part of the configurations or which individual beans should be lazy, should not be lazy, in other words. So, but even though it's not relevant to your question, the point is that yes, that's actually a very common use case where, well, think about it this way. If you have a sync, which is you receive something and then done, right? Where does it usually go? You're not just process it and you said, okay, I got it, right? You probably going to write it to a database. So we have JDBC sync. We actually provide about 56 apps, preset Spring Cloud Stream apps for common use cases, and one of them is JDBC sync, which allows you to basically, you don't have to do anything, you just configure it. It's already, you don't have to write any code. It's going to write to a database of your choice.
Is that implemented as a consumer now, or is it a stream?
I'm sorry?
Is it a consumer, like Java user function consumer?
They're working on it. So there's an effort. So Mark Pollock, the guy who's leading a Spring Cloud data flow. So Sobi and Alaya actually prototyped it already. It's just a matter of converting literally sources to suppliers, syncs to consumers, and processors to functions. They already have a working prototype, so it's just a meticulous work of converting it, because most of those apps were retrofitted XD apps or something. So does that answer your question? Okay.
When the message is considered as consumed?
Another great question. So when the message is considered when your function or when your listener, when your code executed successfully.
Okay, so if we wanted to get something from database and do some transformation and to put it to the other channel, and we got some exception, then it will be not considered as consumed?
It will be. So by default, actually it's a great question, because this is another functionality that we provide as a framework, which is the acknowledgements and transactional rollbacks, right? So if you so in other words, you don't really have to handle your exception or anything. You just have to throw it. If you decide to handle something, just rethrow it. So the container, if you handle it yourself, like it's a very common question in Stack Overflow, like I just, I had exception in database, I handled it, but the message got lost. I'm like, no, the message wasn't lost, you processed it successfully because your method returned successfully, right? So basically, either, if you're calling a method that, forces you to wrap it in try catch block, rethrow from within a catch. If you, yeah, it's the contract of a good old Spring message listener. We don't really have Spring message listener. We have Rabbit message listener. We have JMS message listener. I was talking to Jürgen about that. Yeah. But at least, like, for lifecycle purposes, it could have had some very base interface, because when I was working on the destination binder, I was a lot of the common code, and I was like, Kafka Rabbit. I'm like, it could have ended up in a single container. So I created my own, but with hopes that maybe once it's all nice and polished, then I can talk to Jürgen about this. So move it there. But yeah, any more questions, guys?
What are the strategies to handle failures? I mean, not my code failing, but the network is out or Kafka is down. So is there any way to configure strategies to handle failures outside of my system? Because there's a lot of logic here, so it's just a function. There's network somewhere, so there are failures. So is it up to the network, to the driver, or How does it work?
So I only heard part of the question.
The
So
question is, you can have network issues.
of
For
course,
example, you will not be able to, like, due to network issues, send a message or store something. So how can you handle it? Right? That was the question?
Yeah, so what's the strategy for handling errors outside of the scope of the function, but when it comes to integrating with Rabbit or Kafka or something? So it's built in the driver, how can I configure it? Is there any default strategy?
well, as you can see, I didn't really have to configure anything to connect to Rabbit. Like nobody really asked that question. Like, how did you connect to which Rabbit did you connect to? Right? There is no configuration to Rabbit whatsoever. True? So how did I connect to it? Right, Spring Boot. So basically, again, default, right? So I'm saying, since I did not provide any additional configuration, right? It went to localhost, to well-known Rabbit port as a well-known default port. If it didn't, so now the first thing, if it didn't, so actually, let's kill the Rabbit. So Rabbit is no longer running. I'm gonna start the application. So as you can see, so this is part of your answer. I mean, application is started, but obviously we cannot send the message. And what's interesting is that we're attempting to reconnect, right? We're trying. So this is one of the ways of handling this connection, right? So in fact, so now I'm going to start Rabbit. Look what's going to happen. And we create a connection, right? So now I can go back to Rabbit and start sending messages, right? And everything works. So now application is running, I'm not touching it. I'm going to shoot the Rabbit again. And we're back to attempting to connect, right? So this is another value that's provided by the framework. So if in a situation where you, and again, for this I would probably have to go into debug mode to hold the code, kill the Rabbit, and then, so in other words, if I already manage to receive the message and then somehow after I process it and I'm returning from the function, that's when the message goes out. At that point of time, connection disappear, the exception will be thrown and the message will be
That's just normal Spring A.
yeah, right. But I'm saying right.
No,
So
acknowledge the message.
right. But the point is that if you look at Spring Cloud Stream, I'm trying to properly assign credit because, as Dave just pointed out, it's good to have him in the audience. It's not really Spring Cloud Stream that does it. It's the messaging frameworks that Spring Cloud Stream using, in this case, Spring AMQP and Spring Rabbit, essentially. So those are the frameworks that are handling, that are taking care of it. So we kind of like look at it as layers, right? So the Spring Cloud Stream, it's a binding framework. It's literally, even when it comes to message conversion, we're relying on just providing message converters, which are part of a Spring messaging, and those themselves rely on type converter, the conversion service and type converters provided by Spring Core. So it's kind of like, we truly eat our own dog food. So
You mentioned once it's like Spring Boot for Spring integration, right? Spring Cloud Stream.
that's one way of. Did you guys hear what he said? So it's like Spring Boot for Spring integration, where it's Spring Cloud Stream is effectively Spring is a wrapper over Spring integration, you can say. But the reason why I don't like to say it that way, it's because I would say it's a wrapper over enterprise integration patterns. We basically have a framework that provides implementation of enterprise integration patterns as Spring integration. But again, there are ways, like we always try to improve certain things, right? And if you're already executing, like when I was mentioning that destination binder, so right now we're binding to a message listener container provided by, right now we're binding via inbound and outbound channel adapter that uses message listener container that uses, and so on and so forth, right? Where I'm saying, well, if I already know that, Like, can I shorten the path between the message listener container and the actual method invocation, right? So in this case, I would have to bypass Spring integration, because unless I'm using Spring integration to build an internal flow, do I really need the adapter here or not? So it was an easy way to get started, but so the future effort, we're considering, okay, well, do you really need that? Because that brings the channel, and with the channel comes the dispatcher, so that there's a lot of handoff happening that may not be needed, especially when it comes to high throughput streaming applications, where you really need to shorten the path between the source and the actual processing mechanism. And like right now with the R socket, which I don't have time to get into, but or to even work with, but ability to kind of go bidirectional and literally just bind directly to with flux and do true streaming with back pressure and everything. So
Spring MQP doesn't even sit on top of Spring messaging, it does it because it's older. I don't know if they have a retro.
Spring MQP, no, but Spring integration.
I'm just thinking there must be an abstraction there.
Well, remember, Spring messaging didn't exist. It was part of the Spring. It was integration, and then we kind of, yeah. There's a lot of things. I mean, well, it's a history of Spring. I mean, how like throughout your career, how many things of yours, from batch or integration or whatever, eventually ended up in Spring Core? Huh?
Not many.
Not many?
So, from another question is, what should we watch out for when building this kind of functions when it comes to the threads that are used underneath? So, I don't know, I should not block, or there's a limited thread pool, or there's unlimited thread pool. Where does it run, and what should we watch out for?
Well, I mean, I would say don't do threads within your function to begin with. I mean,
There is a threading abstraction at the bottom there, right? So with this one, it's Spring AMQP, Spring Rabbit, and the thread pool for the message listener.
right, but I think, yeah.
If I'm going to use, I don't know, let's say, database, so, and I stall for like 2 seconds, and I don't know, maybe something blows up because I cannot process messages or something.
So you can use the reactive thing, right?
That's why I'm asking for the
So this isn't reactive. The web one was. The web one was using webflux. So you kind of have to know actually what stack you're sitting on, whether you can block or not.
Well, no, Dave, the reverse was reactive, right?
Yeah. But, I mean, like if you blocked inside that.
Yeah.
Yeah, but if you're using the flux one, you know that you can't.
But what I'm saying, I mean, I would not use, like, create new threads within a function that's already sitting on a thread from the task executor, because, again, if you open up our user guide, for example, like a lot of people say, listen, like, why would I, for example, consider using threads within my function, right? Because I want to be able to accept as many messages, and I don't care about if I lose them or whatever, and I'm going to start, execute them on a separate thread. Well, you don't need to do that in the first place, because if you, read the manual, you can say, well, there is a task, concurrent task property. You can say, give me, 5, 6, 7, and all of a sudden, these functions are going to be invoked within its own thread pool, within the thread pool controlled by us.
It's a message listener, it's going to be a large thread pool, but if it was the webflux.
Yeah. Right.
So then you probably would want to do, subscribe on or something.
Right.
Flux. If you were going out to JDBC inside that function, you can subscribe on.
You could run Sergey's tool with the.
You see how bad it is.
There's this byte weaving or whatever to see if you have blocking calls.
That is awesome. We should demo that. Have you seen that block now?
I think using some Kafka streams would be similar. Actually. You mean?
Just using their native APIs.
Yeah.
But still, like, you're consuming the stuff, and you can do a blocking call to a database in a shitty way, right? So this is the problem that we're trying to solve, not the consuming thing, because like Oleg said, you can have multiple consumers.
In streaming applications, you don't want call a database.
I mean, people don't want a lot of things, and we have to support those Stack Overflow questions, right? So.
Yeah, part of the problem is that there is the we almost have to like, if we like approach it from pure academia perspective, then you're correct, right? But the reality is that the insurance companies, the banks and whatever, some of them are retrofitting their old J2E, not even JEE apps, right? Like the old stuff, and a lot of code get cut and pasted and everything else. So they say, oh, we can use functions, and they just literally cut and paste the code from somewhere else into this function without really analyzing what it does and the context within which this code is now being executed. It's like I can write a flux function and streaming function, but make a callback to something that completely written in a way where was not really designed for that type of programming. So, and that it happens. It's not, we cannot control that. So Stack Overflow is a good indicator of what people do, and sometimes you have to like bite your lip and be nice.
Kafka streams binder, you can have a function of stream to stream, I think.
Yeah. Well, now you can have, this is something we're going to discuss tomorrow, like a currying, where you can have function of KStream as an input. The output would look like function of KStream, function of KStream. So essentially you're declaring like three partial functions and eventually the output, right? And that's essentially like 3 inputs, 1 output. Again, it's like you have to look at like a function for functional developers. That's like, oh yeah, makes perfect sense. For a non-functional developer, they look at it, that signature, and they're going to say, But
any more questions?
There's more questions than I had last time, and I didn't really do much.
I guess we can we have 10 minutes or so, so we can just have a ask me anything session or whatever.
Maybe we should all get here this way.
Yeah.
People know who is actually present.